we're going to go over a couple of examples, kind of drawing what is actually happening to the electrons. So we'll start with a combination of calcium and fluorine. So this is if we wanted to bond calcium and fluorine together, we need to first start by looking at their valence electrons. So for calcium, according to our periodic table, if calcium is right here, how many valence electrons does it have? 2. And I'm going to keep on with my colors that I used up here. So calcium has 2 valence electrons. I know that it's a metal and it's a cation, so it's going to lose electrons. I'm going to write it in that same color. With those 2 electrons, if we draw its electron dot structure, I use my element symbol, just Ca, and I would put 2 dots on 2 different sides of this symbol. So you could do top and the side, or one on one side and one on the other side, as long as you can clearly see that they're not paired together. And then the other element that we're looking for is fluorine. So fluorine, I'm going to use my green pen because it's a non-metal. It's going to be an anion. It's going to gain electrons. So fluorine is right here. How many valence electrons does it have? 7. So when I draw its element symbol, F will have 7 dots around it to represent its 7 valence electrons. This is also a reminder that it's only valence electrons that participate in bonding. So when I look at these elements, so for example, calcium, normally as an atom, calcium has 20 protons and 20 electrons, but it's only those 2 valence electrons that are going to participate in bonding. All of the other 18 that are in lower energy levels are going to stay that way. They're already full, though those don't need to move around in any way. So for fluorine, I stopped in the middle. 1, 2, 3, 4, 5, 6, 7. So fluorine is the same way. Fluorine would normally have 9 protons and 9 electrons, but it only has 7 valence electrons. 2 of those are in energy level 1 and aren't going to be part of bonding at all. So anytime you draw a calcium, it's going to have 2 valence electrons. Fluorine is going to have 7, but each of them have the goal to become stable and to have 8 valence electrons. Since one wants to lose electrons and the other wants to gain electrons, they can help each other out, and that's exactly what's going to happen. So let me grab this. So fluorine wants to gain electrons. That's why I drew it in green, because it's an anion, and calcium wants to lose electrons. But the situation that we have is that fluorine can only gain how many electrons? 1, because it already has 7, it just needs 1 to become stable. But calcium needs to get rid of 2. Calcium cannot just give 2 electrons to fluorine because fluorine doesn't have space for both of them. So what we can do to start off is we can get fluorine taken care of right away by just donating 1 electron from calcium so that that electron is no longer in calcium's valence shell and it's now in fluorine's. And that makes fluorine stable or happy. So once fluorine is stable, we don't want to mess with it. We're not going to do anything else with it. It's happy. We leave it alone. But now calcium still has 1 electron that it needs to get rid of. So keeping in mind that this bond is between the different elements of calcium and fluorine, the only 2 atoms that we can have in here are calcium and fluorine, but we can bond them in different ratios, so that's exactly what we're going to do. So the 1-to-1 ratio did not work. 1 calcium for 1 fluorine, not everyone was happy. So my options are I can either add in another calcium or I can add in another fluorine. So think about what would happen. If I added another calcium, I would have another atom that has 2 valence electrons that it's trying to get rid of, but no one to give them to, so that's not really going to help me. If I added another fluorine, I would have another atom that has 1 blank space, 1 spot for this electron to go to. So I'm going to go ahead and try that way. The good news is that if you get to this point and you have to add another element, as long as you draw their symbols correctly, you will be able to come up with the right answer, even if you guess the wrong one to add a second of. So I'm going to add fluorine over here. The only reason I'm drawing it on that side is so that it's closer to the valence electron that calcium's trying to get rid of. And this new fluorine also has 7 valence electrons, just like any fluorine that I would add. So I'm going to do 1, 2, 3, 4, 5, 6, 7 valence electrons on fluorine. And the way that this is left is that calcium still has that electron to give away. It's going to give it to fluorine. Now that electron is no longer part of calcium's valence shell, and it becomes part of fluorine's. So now this fluorine becomes happy because it gained the 1 electron that it needed. And calcium is now happy because it was able to get rid of both electrons that it didn't want. Based on what we've drawn, we can figure out what their oxidation numbers are, because on calcium, I had 2 electrons on my valence shell that I got rid of. So by losing 2 electrons, so keeping in mind that losing electrons leaves you with a positive charge. So I lost 2 electrons. My overall charge is definitely going to be positive, but specifically positive 2 because I lost 2 electrons. And then for fluorine, it's looking at just 1 atom of fluorine. So if I were to pick either one of these, they did the same thing. My fluorine gained just 1 electron. Each one gained 1 electron. So the oxidation number for fluorine would be a -1. And the number of calcium atoms that I needed to make this entire situation happen is just 1. I only had to draw 1 calcium atom, whereas over here, I needed to draw 2 fluorine atoms. If I only drew 1, the situation wouldn't work. And then a couple more things I wanted to point out on this example are that the oxidation number, just the number portion of 1 atom, becomes the number of how many of the other atom you need. And the oxidation number of this atom becomes the number that you needed of the other one. So we'll talk about that down here in our crisscross shortcut, but I just want to kind of point that out. And then the last piece of that is how to write the formula. So when you have an actual bond between these two, the formula for a compound that contains calcium and fluorine is not just going to be CAF, but you have to include subscripts to say how many of each of those atoms is actually part of that bond. We are always going to start with our cation, so it's usually going to be a metal. So in this case, I'm starting with calcium, and I guess I'll use the right color. So Ca. And then a subscript is the little number that goes next to it that tells you how many there are. In this situation, we only used 1 calcium, and we don't write a subscript of 1 because having that element there tells you that it's going to be part of the compound in some way. So we just skip the 1 since it's implied. And then what we'll write next is F for fluorine. So my nonmetal comes second. And then we'll use a subscript to say how many fluorines are part of this. And we needed 2 fluorines to make it happen, so this would be F2.